Lesson 4.4 is on constant rate of change. Yesterday you worked with rate of change. So it has to do with the same thing, the change in y over our change in x. Today they're going to add proportionality and linear relationship. Every linear relationship has a constant rate of change. A linear relationship is basically telling you that the graph relationship is a straight line. Okay, it is a straight line. Now, constant rate of change, all linear graphs have a constant rate of change. Constant means it goes up by the same amount. It's consistent, constant. So constant rate of change is what we'll be dealing with today. And then we'll tie proportionality in with it as well. Looking at our first example here, it says identify linear relationships. It says 1, babysitting. The amount of babysitter charges as shown is the relationship between the number of hours and the amount charged linear. If so, find the constant rate of change. If not, explain your reasoning. So we need to determine, is this linear or not? And if it's linear, it has a constant rate of change. The easiest way to pull things from a table to determine if things are linear or not is go ahead and just do this right here to see if it's all constant. So we go from 1 to 2. That's a 1 hour increase. 2 to 3 is a 1 hour increase. 3 to 4 is a 1 hour increase. Everything is constant on that side. Now they have to be constant with one another, our charge. So we go from $10 to $8 plus 8. 8 to 26 plus 8. 26 to 34 plus 8. So if you look at this, everything is constant on the left side as well as constant on the right side. So we would have 8 over 1. 8 is talking dollars. This is talking hours. Everything is constant here as well as here. So yes, this is linear. The constant rate in this graph is 8 over 1, or basically $8 per hour. That is our constant rate of change, and we also need to determine if it's linear. Well, if it's constant, it's going to be linear. Next example, in example 2, says the amount a babysitter charges as shown is the relationship between the number of hours and the amount charged linear. If so, find the constant rate. So again, same scenario. Gain an hour here, 1 to 2, 2 to 3, we gained an hour, 3 to 4, gained an hour. Over here, my charge from 12 to 19 plus 7, 19 to 26 plus 7, 26 to 33 plus 7. Again, 7 over 1, $7 per hour. So everything is constant on the right, everything is constant on the left. Yes, it is linear, and that constant rate is $7 per hour. Example 3. In example 3, it says find the constant rate of change. In order to find the constant rate of change for the hours traveled and the miles traveled, interpret its meaning. So it says choose any 2 points on the line and find the rate of change between them. We know this is a constant rate of change. I know that this graph is a constant rate of change because it's linear. The graph, that line right there, is linear. Now, in order to figure out that rate of change from a graph, we talked about it yesterday. It is the change in y over the change in x. Now, your y value is your vertical axis, and this is talking about miles. So miles will be on the top part of that fraction. The x-axis is talking about hours. So hours will be a part of the bottom. Now, it says choose any 2 points on this graph. So we're able to select any 2. So I'm going to go ahead and just select 2 points now. I'll say I use this point and that point, and I can use any 2. I think it's helpful if you go ahead and write the ordered pair by it. So this is 2 and 60. This is an x value and a y value. And this is 4 and 120. X, y. Now remember, this is increasing. So my rate of change should increase. Therefore, it should be positive. So I look at the top part here, and it's talking about miles. I look over my two ordered pairs, and that is 60, 120. Well, how am I going to get a change and end up positive? I'm going to take 120, take away 60, over. 120 correlates with 4, which is my hours, or my x value. And again, it's a change, so I subtract. 60 is going to go with 2 for hours. So when I do this, I get 120, take away 60, I get 60, over 4 minus 2 is 2. Basically what this is saying, remember, it is miles and hours. I travel 60 miles in 2 hours. So if I needed to figure out the rate of change, basically this would be simplified, would be 30 over 1, or 30 miles per hour. So 30 miles per hour would be our answer. And again, it's the constant rate of change because it's a linear pattern. 4. Find the constant rate of change for the hours traveled and the miles traveled. Interpret the meaning. I want you to go ahead. This is very similar to example 3. So remember, change in y over change in x. Go ahead, pause the video right now, work through it. Again, we should get a positive outcome because this graph is increasing. Much like example 3, I've selected 2 points. And remember, my y-axis is talking about miles, and my x-axis is talking about hours, so I have miles over hours. I've used 2 points, and I selected and I wrote those ordered pairs in. And remember, this is increasing, so I wanted to get an increase. So when I used 75 and 50 to get that increase, I took 75 minus 50. I would get 25 over. 75 corresponds with 3, so 3 would be below 75, and then I wind up with 3 minus 2, giving me 1. Remember, the top part is talking miles, bottom is talking hours, so basically that's saying 25 miles per hour would be my constant rate of change. Next part is we're going to bring in, with constant rate of change and linear relationship, we are going to bring in proportionality. Remember, linear, that term linear means the graph is straight. Now, when we talk about proportional, when things are proportional, they have a constant ratio. So we're bringing 2 lessons, 4-2 lesson in as well. So we look at this, example 5, and we need to go ahead and determine, is example 5 proportional? And also, we need to figure out the constant rate. And I know that this has a constant rate of change because the graph is linear. So it says, use the graph to determine if there is a proportional linear relationship between the miles driven and the charge for a ride. Explain your reasoning. First thing I would do here is go ahead and set up a table. Tables help make things easier. We know that it's the change in y over change in x, so charge is my y value. Charge will be on top. X is talking about miles. So here would be my table. And I'm going to go ahead and just take off some of the basic intervals here, 5, 10, 15, and 20. So 5, 10, 15, and 20. And when I take that off there, I get, that's actually, sorry, the wrong spot, not at the charge, that would be the miles. 5, 10, 15, and 20. At 5 miles, that charge is 8. At 10 miles, we get a charge of 12. At 15 miles, go up and hit that line, we get a charge of 16. And at 20 miles, we get a charge of 20. So this is what my table should look like. First thing I'm going to do is I'm going to go ahead and figure out my constant rate of change. My constant rate, and we know it has a constant rate because the graph is linear. So here we go, from 8 to 12, well, that's a gain of 4. 12 to 16, gain of 4. 16 to 20, gain of 4. 5 to 10, plus 5. 10 to 15, plus 5. 15 to 20 is plus 5. Now, this is my my y, and this is my x, change in y over change in x. And that's how we write our constant rate of change. So the change on top goes by 4. The change on the bottom is 5. And it's increasing, so it's positive. So your constant rate of change is 4/5. Basically what that is telling you, it's a charge of 4 for every 5 miles. Now you need to determine, is it proportional or not? And here's how we determine proportionality, is by the ratio. So here's how we set up our ratio. Well, the first one is 8:5. Notice I'm just bringing it down. It's my fraction, 8/5. The next group, 12/10, 16/15, 20/20. The next step you'd want to do is go ahead and start reducing. Well, 8/5 is reduced. This next group is not reduced. We can reduce that. A 2 can go into both. That would give me 6/5. And notice, I can go ahead and stop here. These ratios are not the same. If the ratios are not the same, this is not proportional. Basically what that is telling you is that the charge is not proportional to the miles. Still is linear, still has a constant rate of change. Constant rate of change is just basically telling you that the graph is straight, but it's not proportional because our ratios are not the same. Example 6, same thing. Movies. Use the graph to determine if there is a proportional linear relationship between the number of movies rented and the total cost. Explain your reasoning. So again, I'm going to go ahead and set up a table. My table is the number of rentals here. So number of rentals is my y value. Number rentals. Your x value is cost. Setting up my table, I'm going to go ahead and just steal a few of them off here. Well, we have a cost of $2, $4, $6. So I'm going to say 2, 4, 6, and I like to go out 4 spots there. So the cost of $2, if you put your finger on $2, go up until it hits that line, you have rentals, well, one rental for $2. $4, number of rentals, 2. Cost at $6, go up till it hits the line. 3 rentals. Cost $8, go up till it hits that line. 4 rentals. So there's my table. The next thing I'm going to go ahead and figure out is my constant rate. I know it has a constant rate because it is linear. And that constant rate, looking at this, well, here we go. Constant rate, up 1. 2 to 3, up 1. 3 to 4, up 1. Cost, 2 to 4, 2, 4 to 6, 2, 2. So it has that constant rate of change. That constant rate of change being change in y is 1 over change in x, 2. So basically what that is telling you, it is 1 rental per $2. So there's my constant rate. Now I need to determine, is it proportional? And we find out proportionality by the ratio. If it has a constant ratio or a same ratio, it is proportional. So now I'm going to go ahead and start using this. I have 1 over 2, dropping that down, 2 over 4, 3 over 6, 4 over 8. Now we can reduce this, 2 over 4, 1/2, 3 over 6, 1/2, 4 over 2, 1/2. Notice that all the ratios are the same. They are constant. So you would say that this is proportional. Another thing that I'm going to give you a little cheat sheet here on graphs. It's pretty easy to determine if things are proportional. And maybe you should probably write this down on your graph. If this graph, look at this graph here, starts down at the origin. If it starts at the origin, your graph will be proportional. Look, 6 is proportional. The graph starts in the origin. Look at example 5. Example 5, here's the origin. The graph does not start down there, and the graph is not proportional. So that's another thing that you can check out. If it starts in the origin, the graph is going to be proportional. If not, not proportional. Otherwise, if you're not given a graph, you're going to have to use your table and figure out your ratios. This will conclude our lesson 4.4, constant rate of change.